Right, hi everyone. So today we're looking at equations and identities, which is section 10.6. And as it says, you need to be able to solve quadratic equations with sine, cos and tan theta. And so we're going to get more solutions, as we know with quadratics that's the case. And they give you a couple of sort of quick examples there. You might want to pause and just read through that. The notes for 5 sine squared x plus 3 sine x minus 2 equals 0. Now, I'm going to have a look at example 16. There's two parts, A and B, and let's have a look at part A to begin. So we've got 2 cos squared theta minus cos theta minus 1 equals 0. So I'm going to start by doing a substitution, and I'm going between 0 and 360. And my substitution is going to be that cos theta equals A. So I am left with 2a squared minus a minus 1 equals 0. Now, I can factorise that as a quadratic fairly easily. It's going to be 2a and a. I know it's going to be a 1 and a 1. I just have to get my plus and minus the right way round. And I'm going to need a negative there and a positive there to give me the plus a and the minus 2a for the negative a in the middle. Now, of course, that means that either a equals 1 from this bracket, or 2a plus 1 equals 0, which would mean that a would be equal to minus a half. But it's not a that we're interested in because we're not solving for a, we're solving for cos. So we've got cos theta equals 1, or cos theta equals minus a half. So that's where we're up to. Now for this, we can solve cos theta equals 1 when it's 0 and 360. That's because, of course, we've got a cos bucket, and it starts up at 1, goes down, and then comes back up when it gets to 360. So we've got theta equals a 1 when it's 0 here and at 360. And the other one, if I do arc cos minus 0.5, I get 120. Now the common mistake is to say my solutions are 0, 120 and 360. But of course we need to find any other solutions that are here. So if we go up to 120, 120 of course is in the sine quadrant, which is right because cos theta is negative. And if that's 120, that's 60. The other solution will be here. And so another solution with the 120 will be 180 plus 60, which is 240. So I've got 2 solutions there and 2 solutions there. So again, just to be absolutely clear for any examiner, when the time comes, theta equals 0, 120, 240, 360. Any of those solutions can be used to solve the equation. Okay, so that's part A. Part B is sine squared theta minus 30 equals a half. So we've got sine squared theta minus 30 equals a half. So again, I am going to do a substitution, but slightly different this time. Whereas last time, to factorise it, we did a substitution where a was equal to cos theta. This time we're going to do a substitution to say sine squared a equals a half, where a equals theta minus 30. Okay, so it's a slightly different sort of substitution. We're still doing from 0 is less than equal to theta is less than equal to 360, but now theta minus 30 means our range has changed. So if sine squared a equals a half, we're going to carry on solving here now. Sine a will be equal to the square root, plus or minus the square root of a half, which is actually, if you think that that's root 1 over root 2, and root 1 of course is 1, so it's 1 over root 2, which is root 2 over 2. And again, of course, this is all plus or minus, just to rationalise that denominator. So sine A is equal to that, so we can solve for A. If we put A in, A equals shift sine root 2 divided by 2. Oh. Second function, sine root 2 divided by 2. We get 45, which would be for the positive root 2 over 2. But of course, we could also have minus 45. Okay, so we've got two solutions there that will work. Now, we draw our cast diagram. Mark in our angles that we want. There's a 45, and there's a 45. And actually, this is going to give us another another positive solution, sorry, in that sine quadrant. And we've got another negative solution in the tan quadrant. So our solutions for A, if we take into account that this is our adjusted range for A, would be, well, the minus 30 means that minus 45 isn't any good to us. But 45 is in our range, 135, 225, and then 315. But that's for A, and A is equal to theta minus 30. So in order to work out what theta is, we need to add 30 to A. So that'd be 75, 165, 255, and 345. And there are our four solutions for that one. Now, example 17, I think there's a mistake. You see I've adjusted it here, but this should be 9 sine x. I don't know if that's what your textbook says, but mine said 9 sine squared x. So I'm now just going to go back here, write my equation. And I'm going to start by using one of the trig identities to say that, to convert everything into sine. So 2 lots of 1 minus sine squared x plus 9 sine x equals 3 sine squared x. Expand that out. And then I'm going to take all my sine, everything to the right hand side. So that's going to give me on the left hand side 0 equals 3 sine squared x plus 2 more sine squared x is 5 sine squared x minus 9 sine x minus 2. And then I could do this with a substitution. I'm going to say this is 0 equals 5a squared minus 9a minus, sorry about that, minus 2, where a equals sine x. So that now becomes 0 equals 5a and a, 2 and a 1, and we want to have that and that to give us the following: either 5a plus 1 equals 0 or a minus 2 equals 0. So if we now replace back in with sine, we get 5 sine x equals minus 1. So sine x equals minus 1/5. Or sine x equals 2. Well, immediately we can cross that through because sine x can't equal 2. It must lie between minus 1 and 1. So we just need to solve for sine x equals minus 1/5. So if I do second function sine, negative 0.2, I get x equals minus 11.5 to one decimal place. I need my cast diagram. Minus 11's down here. So that's one solution. The other solution will be in the tan quadrant because we need it to be negative. And again, I've written negatives where I probably shouldn't. Just write what the angle is to the horizontal. So now I can say that my solutions in the range that we want, which is minus 180 to 180. So minus 180, we're going to have minus 180 plus 11.5. Minus 180 plus 11.5 minus 168.5. And the other solution will just be that minus 11.5. They both lie between 0 and minus 180. And in the positive 180 quadrants, up to here and here, there's no solutions. So actually, they are my two solutions. And we're all done. So if there's anything you need to go back over it, have another watch, whatever you need to. But the next thing I want you to do is to work through exercise 10F, slowly but surely, and see what you can do. All right. Anyway, good luck. Any questions, let me know.